Okay, so can everyone see my screen? Um, okay. If you can't see it, let me know. So I'll start by just telling you about myself, saying about my background. I think credibly is always really important, especially with quant research. Like, why do I have the background to teach you quant? Because a lot of people try to teach it and they may not really understand the statistics. So I have a PhD in cognitive science and education. So I did a lot of my quant learning there, especially survey design and analyzing surveys statistically and analytics. And my undergrad's in cognitive science. And then I've worked at a bunch of tech companies, startups, and so I'll show you where I've worked. I worked for Schwab. I worked in ed tech. I did a postdoc in educational gaming at Vanderbilt. I did a lot of work on researching science simulations for kids, and I continue to do that. Um, I worked in cybersecurity. I did some contracting at Facebook. I worked for some fintech companies, and I worked at AWS and Alexa. And I currently work at an ed tech company called Kidim, which I'm going to post about pretty soon. So that's me, and that's my background. So you can feel confident that I know what I'm doing. Um, and let's get started with the presentation. So, oh, hi, Mom. That's my mom, actually. You can turn your camera off, actually. You don't have to keep it on. Okay, that's right. It's your camera's on. So we're going to go over some core concepts in this mini lesson, which is a preview of my full course. So we're going to go over p-values, effect sizes, and confidence intervals. Um, let me see one thing. Oh, good. Henry's here. Awesome. So we have our friends from the course, and I'd like you to meet them. We have Product Manager Parrot. And then we also have, I am user researcher buddy. Oh, crap. My background. Oops. Oh well. Um, Give me 1 second here. I have two logos, and I want to know which one to choose for my Gen AI agentic powered birdseed device. What do I do, Mr. User Researcher Bunny? Well, maybe we could do an A/B test. Let's see what results we get. Okay. Well, I have two. I have the first one that gets 35 clicks an hour. We found that out. The second one gets 40 clicks an hour. And 2,900 bird customers will be exposed to each button. We found a P equals zero point zero 0.05 difference in click rates between buttons with an effect size of 1.5. What does that mean? Oh, let's find out together. So I'll show you what it means, guys. Don't worry. So we have these two buttons, and here are the stats that we have. Oops. So what is a p-value? It means a p-value is an estimation of chance. So if a p-value is under zero point 0.5, it means that you have a less than a 5% chance that the difference in the click rates you saw between these two buttons, the 35 clicks an hour and 40 clicks an hour, are just due to chance. So things can happen in life that are just random. Maybe someone randomly clicked on a button more than another. So the reason why we care about if it's quote from chance or not is if it isn't from chance, it must be from something psychological. They liked a button more than another. A button fit their needs better. A button fit their job to be done better. And so the reason why we want to make sure it isn't chance is because if it isn't chance, it means that there's a driver behind it, a driver such as design, product features, things like that, visual design, and then we know that there's something substantial driving behind it, and that means that enhances the chances that that design truly will do better if we release it to everyone because it's driven by something real, a real psychological factor. An effect size is a percent of the control group, which is below the mean of the experimental group. So I like to use this diagram here. So if the blue is the control group clicks who had clicks under 40, then you see that more than half were under 40. And so let's make sure we get this right. So we have 35 and we have 40. And so we want, if we have an effect size of 0 to zero point 0.5, zero point 0.5 to zero point 0.8, or zero point 0.8 or more, it's telling you that the group that we thought would do worse should in fact do worse across each user, and how many of those people are doing worse compared to the experimental group. We would hope the experimental group might do better. We hope that it has something in it that will perform better. So that's what this is trying to visualize. If you literally took each user in one group and compared it to the other, then it means more of the users in the group that did better. Because across the group, not everyone is going to achieve a click rate above 40. Some people will do less. And so, how many of the people in that group actually did a click rate that was on the higher end? And so, it's a proportion. That's what an effect size is. So, what are the weaknesses of p-value and effect size? So, p-values actually aren't used that much in quant research. It happens to be a staple, but people don't use it that much. Um, Even if you know there's a statistical difference, you need the means of both conditions to understand the magnitude. So here we know that, oops, we have 35 and 40, right? And so we can see how much of a difference there was. Is it something that, from a UX standpoint, we think is meaningful? So you have to at least you have to know the actual mean value. And then the p-value isn't going to tell you why. It's not going to tell you, was it a change in design? Was it a product feature they liked? Was it something else? The marketing copy, whatever it might be. It doesn't tell you the driver behind it. So that's why qualitative feedback is so important. And also understanding the design principles, like in terms of what we know about human-computer interaction, is there a reason why one design would be better than the other? Does one design follow from design principles better than the other? So here, if you had qualitative feedback with 5 users and they demonstrated a strong preference for button two for very logical reasons, you know, their preferences, what the design communicates about the product, I would say a statistical test like a p-value would be less necessary. Let's say all 5 users strongly want this button on the right versus the one on the left in your target group. So you have very strong reasons why they love the design. They say it really communicates the product better, and everyone says it's true. It's not that the p-value might be nice, but it makes it less important. And so a lot of my perspective on stats is like if you're getting amazing qualitative feedback, it makes the statistics less important because qualitative reasoning, it does represent a population. If you have strong reasons in qualitative studies, it's more likely that all more people in your population will feel the same way. So keep all of this in mind when you're looking at p-values and effect sizes. What I actually see a lot in quant research is percents. Honestly, I see a lot of percentages. There's a danger in that because you need to know what the sample size is that gave that percent, but people communicate mostly like 70% of people had like this feature or the CSAT mean was this. And kind of dividing things between groups that really like something or sort of like something or really didn't like something. P-values actually aren't used that much, but they're helpful for something like if you had 2 designs and they're kind of similar and you really don't know which one to release, then you might care more about a statistical difference because that's such a nuanced metric that if you really see that difference, it probably truly does mean one is better than the other. But even then, I'd still want to look at the qualitative feedback and figure out like why are they so similar or what is the reason why you're even getting this difference. So it's good to look at things holistically. Well, let's go over confidence intervals. So we have our friends here and they want to know some more things. What's a confidence interval? Um, it's kind of like if a value, how likely it is it falls between two values because we never really know what the value is. Do you know anything? Yes. Why don't we explain it? Then it'll make more sense. Okay. So we have these 2 buttons, and we have a 95% confidence interval that the 40 clicks an hour falls between 39.89 and 40.11. And then for 35 clicks an hour, we have a 95% confidence interval that falls between 34.5 and 36. So what does this mean? So a simple explanation is it's like your margin of error. The true value, we're 95% confident it falls in between these two numbers. Um, It actually means on a statistical level, if you replicate the experiment 100 times, 95 of these intervals would contain the actual value and the true population of users. If that's hard for you to understand, it's hard for me to understand too. I'll only put this down because sometimes statisticians will get upset if you approximate it to say, oh, it's the likelihood it falls between two values. But don't worry about the real definition. It's super confusing, and the proxy definition is what really helps you and really helps you understand cognitively, like what do you do about it. But just understand there is some other definition if someone gets upset in a meeting. But you don't need to worry about it. So you can use confidence interval calculators where you put in the sample size, the mean, and the standard deviation, and the confidence level that you want, and it will give you the interval. So there's an important way to view this. So you have a confidence interval and you're 95% certain, which is the standard, by the way. Most people don't use 99%. That's very precise. Maybe if there's something that was very sensitive, you had to get a number that was that clear. And most people don't go below 95%. So 95% is really the standard. Let's say your target was that you needed 40 clicks an hour. Let's say for some reason that metric had to be reached. Leadership really wanted this metric. It was really important to the board of investors, whatever it might be. So this isn't that great. Why isn't that great? Because you're 95% certain the value is between 40.11 and 39.8. But you're not, it could be anywhere in there. So the true value could be below 40. So you may not have actually met your metric. If your goal value is 39 clicks an hour, then it's great. Smiley face. Because in the worst case scenario, the lowest end of the range is 39.89, right? And so in your worst case, you're still above 39, so you're doing great. So that's a good way of thinking about confidence intervals. Think about it in terms of what are you trying to reach? And in the worst case, do you reach it in that confidence interval or not? And how much does it matter if you reach it or not? It may not matter that much. How do you make confidence intervals stronger? You can increase the sample size. That should narrow the confidence interval. And so there's the actual number you get is the bounds of it are much smaller. There's less room for error. You can also increase the confidence interval from like 95 to 99%, but the range will be wider. So, for example, here you have 40.1 to 39.89. You may be 99% confident it's between 41 and 39, but then there's a bigger range. It could be anywhere in between, right? So I would say is that if you're unless you're dealing with something super sensitive or someone on the stats team has said you must use this interval and they explain why, don't worry about it too much. Just use 95%. It's what everyone uses, so that's fine. Most of the time, I'd say 99% of the time, 95% confidence interval will give you what you need. Okay, so that's the section on p-values and effect sizes. So before we move on, does anyone have any questions on this before we move on to sampling strategies? Anyone? Feel free to ask. Or you could put something in chat if you like. Okay, great. So why don't we go over why do we need large sample sizes? You use large sample sizes when you have small differences in design you want to test. You might have minor differences in marketing materials. Satisfaction metrics like CSAT, Net Promoter Score, or usability scores, you're often benchmarking them from quarter to quarter, and you need a pretty precise number. There can't be a lot of noise in that number because you're trying to see like, did CSAT really go up with my population of like 10 million customers? So it's important to get precision when you're benchmarking something across the entire company. There are other metrics you might have that you want to benchmark, like trust, connectedness, stress levels, motivation. So when you're benchmarking things for an entire population of users, you probably care more about precision, so you want a larger sample size. You're trying to validate design updates on a larger scale, so you want to A/B test something, and especially if there are nuanced differences. If there are big differences in design, you should be able to see if those design differences make a difference in a smaller sample size study. I'd say a large sample is not as needed. But if it's a more nuanced difference, then like you change the features a little bit, you might need a larger sample to really tell if it's making a difference. And you're trying to validate pain points, product desires, jobs to be done on a larger scale. You did a small and qualitative study. Maybe you did some surveys with just like 10 or 15 users, and you want to see like, you want stronger validation of it. Like you're pretty confident that's true. Again, my philosophy is small n studies often are true most of the time, especially if you're getting really good data, really rich data. There often isn't an urgent need to validate it with a large sample, but it may be something really important and you want to validate it with more users. The other value of having a large sample with validating pain points and jobs to be done is it's easier to parse it based on different groups, different economic classes, different regions, different, personas, things like that. And so it's easier to do that with a large survey and you can see if there are differences, even statistical differences. So when using large sample sizes, think what level of difference are you trying to detect? Big picture issues, you're trying to validate qualitative findings. Do you want something statistically different? Do you want a benchmark? Do you want a minor difference? Then use a sample size calculator to figure out what sample size you should use. There are A/B test calculators online for analytics. There's a population level calculator if you're not comparing groups against each other, like design A versus design B. You just want to say like, oh, I want a survey on people's pain points. I want to represent all my users. Well, there's a calculator, say on SurveyMonkey, that will do that for you. It's a different type of calculation. And if you're not sure, I'll give you some heuristics or ask a stats person. I think I'll give you heuristics in this presentation. We'll see. Oh, there's something in chat. And Henry, my friend in quant research, says G-Power is a great free power analysis tool. That's awesome, Henry. Thank you. That's great to know. And here's something I think is very different than academia that I think is probably one of the biggest things you should know as you're doing work in corporate and for startups and such in the real world. I advocate strongly you look at the qualitative data as you're doing the quantitative study. Because if you're seeing a big difference, like say you have two groups, people with incomes under 30,000, incomes from 30 to 100,000, and you have two designs and you're doing a survey about pain points and design preferences or something, and you thought you needed like 250 users. But you're seeing a massive difference between the groups. Like the people that make under $30,000 a year massively prefer, like everyone prefers design A, and everyone in a sample size of 60 that make above 30% prefer design B. Maybe one design is catered more to the needs of people in poverty and people of less income. You don't need 250 people to get your answer. You pretty much have already gotten your answer. Or if you're trending towards something that's strong, you need probably half as many people. And so the thing is, the way you got to think about it is these users are expensive. It costs money to get these users, and it costs time to get them. And in corporate, you always want to do everything as fast as possible and with the least amount of resources. So a big theme in my course is use the qualitative data, use the trends to figure out the sample size iteratively as you go along. You may need less people, you may need more people, you may need more people in one group, less people in another group. It's really something you're constantly looking and peeking in the data and you're trying to figure out what to do. Now, there are some instances where you will not do that. Often with like very nuanced differences, it may not matter as much unless you are wrong and there isn't a nuanced difference. But corporate is not like academia. This is one of the strongest principles I can ever tell you. Look at the data as you go along. Importantly, look at the qualitative data as you're going along. Let it help you iteratively figure out if you have the right sample or not. You don't need to just figure out from the start. The other thing I want you to know that's really important is that these sample size calculators, they're all estimations. This sample size calculator you get from Optimizely or SurveyMonkey, it doesn't know the particulars of your study. It doesn't know the particulars of your users. It doesn't know the particulars of your designs. All these things factor into what sample you truly need. There's all an estimation. And so they don't know any context about your study. They're just estimating. There's error in it. It's not you shouldn't use these sample size calculators thinking they're perfect. They're far from perfect. They have all kinds of errors. The biggest error of all is they don't know the context of your study. The context of your study absolutely dictates the sample size you should be using. So this concept of peaking in the data is actually it is the gold standard of being smart and getting the best sample size. So as you're going along, look at the data and then iterate the sample. And there's an art to doing this. But please do not treat it like academia. This is not academia. And if you treat it like that way, where you just very scientifically select the sample size and you never look at it again, you never peek at the data, I will tell you you're being very ineffective. Literally, I would not hire you for my company. I would not hire you, and I would fire you if you worked at my company because you are being very ineffective and very inefficient, and you are losing money and losing time. So not only should you feel comfortable going against the academic way of doing things, you are a very ineffective researcher if you do not do this. And that's what I want to leave you with. I want to emotionally convey that to you, that do not treat this like academia. That is the wrong and ineffective way of doing it. Henry says, sometimes in a high sample size study, it's necessary to validate generalizing your low sample size findings because you have a hostile audience being resistant to the messages. Agreed, that does happen. I'll get to storytelling in my course, but agreed, Henry. There's sometimes you do things because it's way stakeholders, and that's fine. I think it's a perfectly valid reason for doing it. If you don't have impact, you have nothing. This isn't academia. You're not publishing a paper in some journal. So you use large sample sizes to compare the means between two populations, to A/B test different designs, and even marketing messaging. I do some market research in addition to user research, and sometimes you just want a sample to represent all users. You're not comparing anything. You just want to know if, say, the top three pain points you found in a qual study are truly the top three pain points across millions of users. Okay, so you want more quantitative validity behind your findings. Okay, so those are the three main reasons. This image represents the idea that use your customers and users as a guide in the survey or analytics themselves. Again, it's this concept of not only should you not feel bad about peeking at the data, you're very smart and efficient if you do peek at the data. Your users will start to unfold a story about your data as you start doing it. If that story ends up being very strong, you're going to need less users. If the story isn't strong, you may need more users to figure out if there truly is a difference. Sometimes you find out there is no difference or there's no meaningful difference. Well, that is your finding. And then you got to figure out why. Maybe you need a different design that's more striking. Maybe it really doesn't matter which design you choose. It's irrelevant. Just pick anyone. It's not important. Those are your findings. Okay, so let's go back to our friends. I want to compare the CSAT between robins and parrots. Okay, let's see what to do. How can I figure out what sample size to use to compare their ratings to detect differences? Although I already know that parrots are better than robins, so their answers are probably better. That's very biased. No, it's not. I'm a parrot. Represent all parrots. That's literally what bias is. And we need to talk to HR about these biased views you have against other species. No, not HR. Well, never mind. They're all equal. Good. Okay. So if you want to find the sample size compared to means, there are calculators you can use. Like you put in the confidence interval you want, the power that you want. Normally that's 80%. The difference you think will be between groups. Now you're probably wondering, how do I know the difference between groups before I do anything? Okay, that gets at peeking at data. We're going to get to that in a second. The population variance you may know. Um, from something you've done before, you may not know. Some of these calculators are just not easy to use. It's truth. In my course, I go over more heuristics that can help you when you don't know things or how you use peeking the data to figure things out or when the qualitative feedback actually tells you more than the quant feedback. But I'm just giving you a preview for right now. If you want to know more, you got to sign up for my course. Um, so how about you figure out the variance, the variability in the population, or how about you estimate the difference you think there's going to be between two groups? You're like, how would I know the difference between both groups? I haven't even run my study yet. Well, you're going to guesstimate, first of all. You might have past survey results, or you might need to pilot the survey to get a sense of what you think the difference is. And then when you have that data, you can use Excel functions to figure out the variance. If you're still unable to do it, you can use a heuristic to estimate what sample to use and monitor the results. So maybe you do like 30 or 40 per group, and then you compare them against each other, and you see what kind of results you're getting. Is it statistically significant? So it's a mix of like, if you have past data, can you get some data, some pilot data? And then can you just use a heuristic like this, 30 or 40 per group, and then use that to try to figure out if you're getting the results that you need? Again, you can always pick the data, and it's smart to do so, and you're actually very inefficient and a bad researcher if you don't. In most instances, there are some instances where you should not do that. But for the vast majority of things, peeking the data is the smartest approach you can ever do. Again, my tagline, it's not academia. Do not make it like it. You're not publishing in a paper that will get you nowhere in your career and you will get fired and no one will hire you. And I wouldn't hire you. So, okay, great. So that's the section on large sample size selection and some principles. Does anyone have any questions on this before we move on to a very exciting topic of using AI? Anyone? Okay, cool. So let's get to using AI. Um, okay, so sharing my screen here. So I used Kaggle to get this data set. I want to alert you to what Kaggle is. There are a lot of cool data sets. This is a data set about CSAT data, and um, it has like use cases. So you can find different data sets to explore on Kaggle. I think it's great for getting practice with quant research, and you can post it to LinkedIn. There are lots of things you could do. It does make you more desirable in the job market when people can see that you can crunch real data. And it's one of the best ways to get better. Probably the best way to get better at doing quant analysis is just to do it. So I got this data set from Kaggle. And so I'm going to do is I'm going to go to a Google Collaborative notebook. So Google Colab, and those notebooks are available online. Okay. And okay. So I'm going to make a new notebook. And there are other things you could use, but I like Google Cloud for data analysis. I feel like it traditionally was used for that, and so it tends, in my mind, to be really good at it. But you can use other things. There's even Gemini you can use in the data set itself if you want to, if it's online. So I'm going to upload a file here. Oops. Sometimes it takes a little while to work, so okay. So I'm going to get CSAT data. There we go. So upload my data and then make sure you can find Gemini. Where are you? Go, oh, here it is. Okay. So I like to put it on the side. So I'll say, okay, can you tell me the major fields in this data set? Okay. Oh, okay. So it's going to run it. And you can see the Python code here. And it's telling me the major field so I can see what it has. So it has how likely you're going to recommend, how would you value what you gain, how frequently are you using the platform, the overall quality of the products, the usability, and their understanding. That's qualitative. Okay, I think this actually might have a multiple choice question. So I'll say, okay, can you make bar charts for each major variable, please? I like to be nice to AI because I don't want to lose my human social skills as I use AI. So I think please and thank you is a good practice, but you do what you think is right. So it I always hit accept and run, and you can see it's great. Like you can see the code it's running. Okay, and then let's see what it comes up with. Okay, it's still working. Oh, I like AI. Pay attention, I learn something. Yeah, then I won't need you. What? No, you still need to use a researcher. Why, if I could do it all myself? You need him for other reasons like impact. Okay, fine. Okay. And it does have errors sometimes. Let's see. That's actually okay. And it doesn't always have to do everything perfectly. Let's see if it runs it. Okay, it said it created all the bar charts. Oh, here they are. Okay. So it's good. You could see like what scale it used, and you could get a sense of the data by looking at it. And so let's see. It looks like a lot of people are recommending it, and the value gain is actually pretty high. They use it fairly frequently, depending on what their goal was. Okay, so we're doing some things. So I'm going to do is just for the sake of showing you what you how you can use stats on it. I can have it divide. Let's see. How likely are to recommend a friend or colleague? So I can say, can you divide how likely they are to recommend the product into two groups? High recommend, which would be six or higher, and low recommend, which is five. Okay, so we're going to divide it into two groups, high and low, and you're going to see why. Okay, so it's going to do that. It's going to create my group. Okay, so it should have made that group. So then I'm going to say, hey, as I look at this, rate the value gained from the company. So I said, is there a statistical difference, speaking of p-values, between high and low recommendation groups for how they rate the value? They rate the value you gain from a company. Okay. So it's going to run a t-test, which is what we want it to do. Okay. Failed because recommendation group count. Okay. I think it didn't understand what that was, so I'll try again. Sometimes you need to explain things very explicitly. Okay, recommendation group. Okay, so I'll say, and it said, let's see, is there a recommendation group column? It's actually good that you're seeing this because it does make mistakes and it does sometimes say it did something and it doesn't. And so it's good that you're seeing this because you can see like with AI, you do need to work a little hard sometimes. So it says that it exists. Okay, now it did it. Okay. So great. It showed that there's a p-value of 0.00, which means there's a statistical difference in the value gained. High recommend was 4.3, and there's 2.7 for low recommend. So you can see how you used Gemini to ask it to run a p-value. You didn't need to do it yourself, which is great, right? So now let's say, can you tell me the confidence interval and effect size for this difference, which is what we learned about today? Okay. So then calculate the 95% confidence interval. Okay. So it says a 95% confidence interval for the mean difference. Uh, the mean difference. Okay. Long as doing the difference between the means and it's like you want that. But still, it shows you that you can do it. Let's see. It's 95% confidence between 1.4 and 1.7. It gives you an effect size, which is very, very big. Um, and I want to see something else. I want the confidence interval and effect size for the mean. Um, see what it does there. I want to see the confidence interval for the mean itself for value gained. Let's see what it does. Here we're not comparing anything. We just want to see the mean itself. What's the confidence interval that it is that mean? So it says the confidence interval that the mean calculated, the average in the survey 4.27 is between 4.23 and 4.305. Um, okay. Yeah. The effect size, I need two groups for. But um yeah, so it means that it's this number there it's we can be pretty confident that this is the true number, right? Effect size I have to compare two groups. Sorry, I should have put that in there. We'll do that next time. But yeah, this was a preview, but I hope you can see how you can use Gemini and you can even see the code if you want to learn more Python or you want to tweak it somehow. But you could use it to run p-values in the survey and calculate confidence intervals and effect sizes. Pretty exciting. In my course, I'll go over doing regression models and machine learning models and ANOVAs and more advanced statistics and a lot of other things. But does anyone have any questions as we're concluding this session? Anyone? Mm, okay, great. Let me put my LinkedIn before we go, and you can add me on LinkedIn. Sarah, I'd love for you to add me on LinkedIn. I can give you more advice and tell you more about my courses, and I'll give you a discount because you're a PhD student, so don't worry. I'll give you a nice discount on the course. So everyone, here is my linked. Oh crap, sorry, that's not right. Give me 1 second.
Yeah, perfect. I think we're actually already connected on LinkedIn. So yeah,
Oh, perfect. Well, yeah, if you could send me a DM, that'd be great. I would love to talk to you more about the course and get your feedback. And let me just turn recording off because I wanted to ask you something. That'd be great, actually. I have to turn the recording off. And thank you, everyone else, for